Hey guys, so in this video we're going to be going over finishing up section 1.3 from Griffiths chapter 1. And in this video we're going to be going over continuous probability. The last one we were talking about discrete probability, and this one we're moving over into continuous. And the leap between the two isn't that much. So the main object of discrete probability, was just the probability of getting the jth element, right? But now our probability is going to be between a range, right? Because the probability of getting exactly the, x equals 1.00000 instead of 1.000001, the difference between those two is going to be, very small. So instead of just saying probability of x, which wouldn't have a meaning in continuous probability, we have to do the probability of a range. So let's say the probability of getting x between a range of a and b. And here in continuous probability, it's going to be equal to the integral from a to b of what's called the probability density function, which is going to be extremely important for us, times dx. So if you remember back from the very first, actually I think it's the second video on the statistical interpretation, we can remember that this looks very similar to the integral from a to b of the absolute value of psi squared dx equaling the probability. So we can see that psi squared is actually equal to a probability density function, which is incredibly important, right? It's an extremely useful result. And so now I'm just going to show you how to make, how to compute some variables with continuous, using our continuous form. So if we want to find the expectation value of x, instead of a sum, we're going to have an integral. So it's going to be the integral, and it's not going to start from 0 because real numbers, they start from negative infinity, that's ugly infinity, all the way to positive infinity of x times the probability density function dx. So this is continuous. Remember, for discrete, it was just the summation of, j times p of j was equal to the expectation value. So you can see there's some similarities, but there's some differences. So our sum sign was replaced with the integral. Our variable still stayed there. P of j was replaced with the density. So remember, the density was p of j divided by dx, and then we have to multiply this thing by dx out here. And so you can see that this is just the probability density function, so integral of j, probability density function of j, or let's say call this dj instead of dx. And we can see how we can get to the continuous form from the discrete form. Okay, I think that's a useful thing to see. All right, so now we can again generalize this expectation value to any function of x is equal to the integral from minus infinity to infinity of f of x times the probability density function of x dx. And again, very similar to the discrete form, which was just f of j times p of j. And then we can compute the variance in using the exact same formula. This is just going to equal to the average of x squared minus the average of x squared, right? And then from this we can calculate the standard deviation. So really this is continuous probability in a nutshell. Now we're about to go through some of the problems for probability that Griffiths goes over and work through those, and that should solidify the last two videos.